lambda 2 or the multiple of lambda 2. That you need to see, okay? Condition. The relation between phase difference and a path difference. Sometimes you need that as well, okay? All right, so let's review, because this is very important. Let's do one question, okay? And from there, we will solve the first question and then we will proceed from there, okay? So I want you to, everybody, to make a note of this, okay? Because this is not, I'm not giving that on the slides, but I want you to make a note of it so that it can help you in WebAssign as well, okay? So what it says, the question says, like in a double slit experiment, if the wavelength of the light is 520 nanometer, so I'm just writing what is given in vacuum, because this wavelength also depend, this 520, whenever it's given, or if it is not given in any medium, it's understood that this is in vacuum, but sometimes they specify as well, because in a medium, if you recall, in a medium, the wavelength in that medium would be the refractive index. You have to divide that with that. The wavelength decreases. We know that, right? If the wave is coming and enters into the denser medium, its wavelength decreases. Frequency don't decrease, wavelength decrease. So, okay. So let's suppose this light is in a vacuum, its wavelength is given, and the separation between the slits. So what is given? So if this is a slit and this is a screen, separation is this one, right? So this we normally treat as small d, and that's given as 1.4 into 10 raised to power minus 6 meters. Okay, so this is in micrometers. So this is the L. I don't, right? It's not given. So now I am making, okay. So it's saying determine the angle that locates the dark fringe for which, for basically the first dark fringe. The first question says determine angle made by first dark fringe. Okay, we have been given only lambda and d. So how do you determine? We need to find a first dark fringe. First of all, this is a central. Here, this is a first dark fringe, or this is a first dark fringe. So I need to find basically this angle, theta. Okay, and we know that the delta is d sine theta. We can find theta, right? But we need to have delta, and but the condition of the dark fringe, we know that that's what m plus half, right, lambda. So we can use any of the relations. So I don't need the delta, I just need these two relations. I know d, I want to find theta. If I know m, I know already the lambda is here. Now, here I was specifying, right? First dark fringe means m as 0. Do not take m as 1, because this is the first dark fringe. So this becomes your sine theta would be m plus half lambda by d, right? And this becomes 0, so this becomes lambda by 2d. Okay, and put in the values, you will get theta as 11 degree, right? Because this is sine theta. Sine theta has some value. I don't know the middle. You can put that value, right? So this becomes, what is your lambda? 520 into 10 raised to the power minus 9 divided by 2 times. What is your d? 1.4 into 10 raised to the power minus 6. So this becomes 260, and this is 1.4 and minus 3 or whatever. You can do that, and your lambda theta value is this one. Okay. Now, can you determine the angle made by first bright fringe? Okay. So for first bright fringe, my d sine theta has to be m lambda. First of all, the condition of the bright fringe is this one. Now the first bright fringe, m is 1. Okay. So you have to find this. So your sine theta would be lambda by d. Okay. By putting that, it becomes twice of the other one. Actually, you don't need. Sometimes you don't need as well, because it's always, if you get the dark fringe, right? The angle, the bright fringe angle would be the double. Okay, because this is exactly the half of that. So if you remember, our dark fringe was 11 degree, so this is 22 degree. Okay, so can you try that? If I ask you, what is the angle made by fourth dark fringe? Okay, so what is the condition? First of all, dark fringe, d sine theta, m plus half lambda. But now my m becomes 3. Okay, because this is the fourth dark fringe. So this becomes d sine theta is 3 plus half, 3.5, basically 7/2 lambda. And then you can always find it. If I say, what is the angle made by the central bright fringe? So you say, okay, d sine theta, again, the condition for the bright fringe is this one, right? For the central bright fringe, m is 0. So your d sine theta is 0, your theta is 0. Obviously, the central bright fringe is at 0 angle, because this is made a 0 angle from the center. Okay, in this way, we do the interference. Okay, now let's go and with the chapter. All right, so this was done, and so yeah, the other thing is we did that the phase change, the change of the phase due to the reflection means whenever a light is reflected from a medium of lower refracting index to from the medium of higher refractive index, there would be a phase change of 180 degree. Means how much is the path difference? The path difference then? Can you tell me? I wrote that in my notes. If the phase change is 180 degree, how much is the path difference?
Is it lambda over 2?
Yes, very good. Okay, it's a lambda over 2. So it means whatever be the condition for the constructive interference now becomes a condition for the destructive interference. If only one light, if the two rays interfere, one is reflected and one is not. Okay, so for example, here for a thin film, so if I do that, the first ray is reflected from the surface A. So this reflection, because it's going from lower refractive index to the higher refractive index, and it is reflected, right? So this becomes 180-degree phase change, the ray 1. But the ray 2 is reflected from the higher refractive index, right, to going to the lower refractive index. So it doesn't change any phase. So now the difference in the phase between these two is 180 degrees. Okay, so if this is a 180-degree phase change, means the path difference is lambda by 2. If the path difference is lambda by 2, means this is a condition for destructive interference now. So if you see that, you can see the constructive interference now it becomes m by half, m plus half. Although the others will take care, right? That T will be the thickness of the film, and 2 times n. N is your refractive index. That also we need to count that. So that 2T is m plus half lambda n, and this lambda n is what? Lambda by n. If I place that, I get these two relation. But the only thing you need to remember is that now this becomes a condition. Earlier, m plus half was a condition for destructive interference. But now this becomes a condition for constructive interference. That's why in a thin film, you see a different colors. Okay, so this becomes a constructive interference, and the conditions are swapped basically. All right, and we did some problems yesterday, and it's 15 minutes, so we can continue with that. So the next thing we wanted to talk about is the Newton's rings. Basically, this is another method for observing the interference in the light wave. Okay, if we place a plano-convex lens on a top of flat glass surface, for example, look into this picture. There is a flat glass surface, and if I place what I'm placing is that a plano-convex lens. So convex lens is basically a lens which is curved, right? And this convex lens, right? And the other side is not the lens. So you can see, right? Convex lens is basically normally is bulging from the inwards, right? Like basically fat from inside and thin from outside. And this is always converging, right? Converging to some point. So let's see this be the radius of curvature. Now, imagine everything you are doing. You did that in the last chapter. On the x-axis, this becomes a y-axis because this is upside down, right? So if you place a plano-convex, means one half is cut down and becomes a plane, and another half is still be the convex lens, and that is placed on a plane glass surface, right? And with this arrangement, you can see that there is an air film between the glass surface, right, and the lens, and that air, it varies with the thickness, right? From 0, where the air surface, the thickness is 0 at the central point, right, at the point of contact, to some value, let's suppose this P be the point, right, to at any point P which has some value between them.